Hi everyone, today I'm going to do a little screencast about how I use GeoGebra to introduce the concept of derivatives by first principles. So here we go. First I'll need a function which we can just have anything we like. Let's go a nice simple little polynomial. Why don't we do a cubic, and we'll make this a bit more interesting. Let's go plus 4x minus 3. Alright, so there we go. Now I'm just going to resize the screen here a little bit. So, alright, that'll do nicely. So what I want to do for derivative by first principles, of course, is talk about the idea of a secant, a line cutting through the curve at 2 points. So first thing I'll need is a point. I'll label this point A, which is fixed to my function f. Now I can drag that around wherever I like. So far I've only got a single point. Now because I'm talking first principles, I need a second point, and I want the distance between point A and the second one I'll call point B. I want the distance for that to be able to change. So I'm going to introduce a variable h here, and I'll use the command slider. You'll see what this does in a moment. So the minimum value will be 0. Let's go the maximum value of say 2, and let's go in reasonably small increments of say 0.01. At the moment the value of h is just a variable in the computer memory. It's not actually doing much. So if I set h equal to say 1, now what I'd love to have here is another point B, which the x-coordinate of B is going to be 1 unit greater than the x-coordinate of A. I might just slide point A onto somewhere convenient. Oh, that'll do. So A can be this. A is roughly at 4. Oops, that jumped in and did something without me expecting it. So here we go. Point B will equal. Now, I'm going to specify that I want the x-coordinate of A plus h. So that looks quite a bit like what we would write in a derivative by first principles type of a statement. We would normally just write x plus h. However, in GeoGebra language, we need to say we want the x-coordinate of this object A. So that will pick up 4.01 and add 1 to it. Now that's only an x-coordinate. The y-coordinate of point B has to be the value of the function when we substitute this. So I literally put f brackets and then I type the same thing, the x-coordinate of A plus h. There we go. Point B is now dynamically linked to point A. If point A moves, then point B also moves, staying 1 unit in the x-coordinate away. If I change the value of h, then point B can come closer and closer. Ultimately, if h equals 0, point B is on top of point A. Their coordinates are identical. So that'll be interesting when we do that. Now I need to have a line from point A to point B. Beautiful. I can tell the gradient of the line just by looking at this here, can't I? If I really wanted to, I would what would I do? If I wanted to be a bit more instructive, I'd probably draw a triangle here, wouldn't I? So I'd need a different point, like point C, in the corner of this triangle. Now what is point C going to have? Point C will have the same x-coordinate as B, so that's the x-coordinate of B. The y-coordinate of point C should match the y-coordinate of A. So there's point C. Nice. I could draw a line segment. So the difference between a line and a segment, obviously the line goes forever. The line segment that I'll draw first goes from A to C. It has a value 1.22. And then I'll have another segment from point C to point B. There we go. Now I might do a right click, a left click there. That brings up a little menu where I can change the properties of this line segment object. one of the properties I'm going to change is the label. I might label that run, and I think I'll show the value as well. So that tells me basically the value of h, doesn't it? And I might change the name of this one to be rise. And I'll show the value of that one as well. So that's 58. Interesting. So rise over run. Now, the gradient, of course, the gradient is stored here. The gradient is 47. That's the gradient of line G. Yes. I might just capture that as a single value. So I'll write the slope of line G. There we go. Nice. So I've got all of these things, and of course it's drawing a little triangle there. I might hide that blue triangle because I've got this triangle that changes as I move my slider. Now, why did I do that? So that I can use a text object. If I go to the tool menu and then I go to text, I can start typing some text. And I might type, here we go, what am I going to type? I think I'm going to type something like this. So I'll use, now if you're not familiar with this type of script, then there's heaps of places you can find out. So if we just look at the preview window, you can start to see what I'm typing. So this is LaTeX, which is a typesetting thing. That's fine. Now, what do I need next? I need to say that that's the limit, and I need to use, I think it is right arrow. Yep. And then I put, oh, I know what I should have done first. I should have gone, I think I should have gone like that first, and then H approaches 0. Sorry, H approaches 0. Yep, that's better. Now I need a fraction, don't I? And what's the top of the fraction going to look like? Well, that would be f of x plus h minus f of x, and the bottom would be h. Yeah, that looks pretty good. Let's go with that. So that's now typed there, and that's should be, I hope, should be fixed to the screen. Oh no, it's fixed onto that point of the grid. That's fine. So that's lovely. Now, perhaps it would be good if I was to, let's just edit that. Now I'll come down here, and I'm going to go into the advanced bit, and this little tab here, not just preview, this little tab gives me access to all of the things that we had calculated. So I really want to have another fraction here, don't I? Now, what do I need to have on the top of the fraction? That would be the thing that we call the rise. And if I click that, it'll dynamically use the value stored. Then I want that to be the run. Good. And then I want that to equal the value stored for gradient. So let's see what that does. There it is. So the value 61 is now there, 1.27, and the gradient is 48.5. Can I move that? Yes. There we go. Now the nice thing is that as I change everything, the calculation updates, and of course as I get closer and closer to 0, then the gradient of that secant running between point A and B is getting closer and closer to the value of the gradient of the tangent. Even though these are going to get a bit difficult to read, we can still read the things up here. So it gets smaller and smaller and smaller, and that's the magic. That's, of course, the reason why when we explain this to our students that we have to take a limit. Because if point B and point C actually coincide, 0 divided by 0 is an indeterminate form, and so you can't say, obviously, what line would be running between those 2 points. There's no longer 2 points. Okay, that's my little demo that I use when I'm in class, explaining the idea of derivatives by first principles, and I build this usually in front of the class and help develop the concepts, and then the students, obviously, if they want to, they can follow along and build it themselves. All right, hope that helps, and thanks for watching.